Hello and welcome to Azure Makes, where today I'm going to teach you how to make a bomb. All of the electronics will be fully functioning and okay, wait a second, it's a video game. Counter-Strike was, for better or for worse, a very formative part of my adolescence. During high school, when I had endless time to burn, I spent a lot of it getting good at the game. I spent hours DMing to refine my aim, learning nades, and watching professional matches. This was back when children could gamble using skins, which I did a lot of. Sweden had the strongest professional scene, which is definitely not the case anymore. What up now, Swede? Kenny S was in his prime, and Source 2 was literally a meme. Since then, I went off to college and got a degree in computer engineering. I started my career as an embedded hardware engineer designing circuit boards, and Counter-Strike 2 came out. Sadly, now that I'm a cog in the machine that is American late-stage capitalism, I don't have as much time and energy to spend on things like Counter-Strike. One night, when staring longingly at the Q button, trying to decide if it was worth it to gamble my hard-earned evening away attempting to get 4 functional human beings as teammates, I stumbled into my inventory and found myself looking at the C4 model. Wait a second. That's a circuit board. I know how to make those. And that's a simple LCD. And I have a 3D printer for all these other parts. Also, it would be pretty cool to create a piece of memorabilia for a very formative part of my life that I can't directly enjoy anymore. The first order of business was to look at the C4 model and take note of all of its details. In terms of accuracy, I set my expectations really high. I wanted this to be the best replica of the Counter-Strike C4 ever made. I wanted this thing to really instill a primal sense of fear when the beeping and LED blinking speeds up. Oh no! To do this, I needed to get started by formulating a rough plan for how I would accomplish each of the aspects of the C4. I would need to 3D model and 3D print the blocks of explosives and wrap them in brown paper. I would need a display, a custom-made circuit board with a microcontroller on it, a keypad, a toggle switch with a cover, a 9-volt battery, an RGB LED, a piezo buzzer tucked away somewhere to generate the beeps, some duct tape, some cosmetic capacitors, a heatsink, some paper labels, a bunch of connectors, and a bunch of wires and cable assemblies with various types of plugs. Simple. The next step was seeing if I could find the important components of the model that I can't make myself, which are the LCD module, the keypad, and the power switch cover. These are some of the most recognizable and central aspects of the model that need to be very faithful and accurate if I'm going to make a good replica. Luckily, Counter-Strike has an extremely realistic art style, and whoever at Valve made the C4 model thankfully seems to have used a lot of real-world inspiration. Liquid crystal character display modules are widely available in many types and sizes, as the technology is really old and well established. The LCD on the C4 happens to be a single-line display, which limited my options as single-line displays are actually pretty uncommon compared to 2- and 4-line displays. I was still able to find a couple options and eventually chose this one because it had the right backlight color and had a controller IC that should work with the Arduino library that I plan to use to drive it. There are lots of switch covers available to choose from, but I wanted one that matched the exact shape of the one in the model. Luckily, I found this one, which is pretty much perfect. I didn't have high hopes for finding an exact match for the keypad, as the font, coloring, and shape combinations seemed to be pretty unique. To my surprise, I was able to find a perfect match, and I ordered what I think were the last 2 on Amazon because they haven't restocked since, and it's been a few months now. For the smaller components, I got a cheap piezo buzzer, a simple through-hole RGB LED, some capacitors that match the appearance of the ones on the module, and a heatsink roughly the correct size that I just had to spray paint silver to match the model. Now having all the dimensions of the parts I was going to buy, I then modeled everything in Fusion 360 to work out the unknown dimensions of things, such as the PCB and the various parts I planned to 3D print. The next step was to make the circuit schematic. For the microcontroller, I chose to go with the tried and true Atmega 328P. This is the microcontroller used on the classic Arduino boards, and while it's really old, it's still relatively cheap and exceptionally easy to design around and program. Speaking of programming, this ICSP pin header is needed to let me upload code. For various reasons, it's very useful to have an LED driven by a microcontroller pin for general use. To power the circuit board, I'm going to be using a linear voltage regulator to bring the 9-volt battery supply down to 5 volts. It can supply a current up to 500 milliamps, which, according to my very careful math, should be good. This part can take an input voltage anywhere from 6 to 35 volts, which means I'll have some flexibility when it comes to the power supply. And spoilers, this will be important later. Obviously, there needed to be a connector on the board to plug in the power source. The in-game model has a JST connector, so that's what I used. This diode will prevent me from killing my USB port in certain situations. It's good practice to add test pads and indicator LEDs at the different power levels of a board to help indicate any power problems, so I included those. Moving on to the various peripheral devices in the design, there are pin headers to connect the LCD module and the keypad to the circuit board using jumper wires. The RGB LED I chose has 4 pins, one for each color and one for the common anode. Piezo buzzers only use a single pin that needs to be driven by PWM from a microcontroller, so that's very simple. At this point, I can add up how many I/O pins we need to control all of the devices and find that we need 27 pins. This is a problem because our microcontroller only has about 20. Because of the large number of pins required to connect all of these devices, I need to add an I/O expander chip. I went with the MCP23017 because it's a very popular and cheap part. To finish the schematic, I added all of these cosmetic parts that are included on the PCB in the in-game C4 model, but don't actually electronically matter, so they aren't connected to anything. And that does it for the schematic. Moving on to the PCB, it took me about an hour and a half to lay it out. It matches the in-game model pretty well, so I'm happy with that. I added a little disclaimer on the back that probably won't protect me at all, but I had to try. Now it's time to order the blank boards and the parts. After about a week, I received the PCBs and the components and got to work building a board. This is definitely my favorite part of working with electronics, and you know what? Why don't we do a little montage to try to get you excited about it too? No smoke. Nice. Next up was to write the code for this thing. This is the part of the timeline of most electronics projects where you have to contend with all of the incorrect assumptions and miscalculations you inevitably have made up until this point. Thoughts ranging from, well, that was silly of me, to, what in the holy fuck was I thinking, involuntarily enter your mind palace. You wonder how you could have possibly ingested such a large volume of hallucinogens while you were designing and not remember it. Nevertheless, you push through and take comfort in the fact that you'll learn from your mistakes and do better next time. After I fixed all the little mistakes, I found libraries to drive the LCD and the I/O expander and began writing the rest of the code to perform the logic needed. I started with the big task first, the LCD. Let me come clean with you. Up until this point, I've shielded you from the painful realities of driving the LCD for this project. You see, the Valve developers did a really good job making the C4 model realistic, but they took one very important liberty that made this project much harder than it otherwise would have been. They put the LCD on the C4 upside down. But don't worry, I got this. I wasn't gonna let a little adversity stop me from building this thing. I want to proudly display this on my wall. I want it to remind me of the good times I had playing CS. I want to scare people. Oh shit. Let me try to explain the complexity at play here. And put on your thinking caps because this shit gets a little crazy. The LCD has 16 positions for characters. Characters sent to the LCD are displayed left to right, as you'd expect. This means that you need to send an appropriate number of leading spaces if you want to center the text, which the C4 does. But as you can see, the digits of the code are spread across the whole display, not jammed into the middle like this. That means you also need to add spaces between each digit to spread them out. At this point, you might be thinking, this isn't too bad. But let me remind you that the LCD is upside down. This is where the concept of custom characters comes into play. Thankfully, most LCDs allow you to display custom characters that you define using a binary map of the 5x8 pixel area of a character. I made an upside down character for each digit that appears in the C4 code and used those instead of normal characters. Now, technically left to right is actually right to left, which means you need to reverse any output you're sending to the LCD. A weird quirk of single-line LCDs is that they're actually internally structured as two-line displays, with the first 8 characters being considered the first line and the last 8 characters being considered the second line. But remember, left to right is right to left, so the second line is actually the first 8 characters. One more thing. In the game, there are asterisks that act as placeholders for the digits that haven't been entered yet. This means that you always need to add asterisks onto the end of the output until the string is 7 characters long. Okay, let's try this from the top. Let's say the user has entered 735 so far, and you're going to print this on the display. First, you need to append asterisks until the string is 7 characters long. Next, you need to add spaces to center the digits and spread them out. Next, you need to split the string into 2 halves. Then you need to reverse each half. After that, you set the cursor of the LCD to the start of the first line, which is, confusingly, the rightmost character. Next, you print the custom upside down character for each digit in the second half of the string. Lastly, you set the cursor to the second line and do the same thing for the first half of the string. Congratulations, you have printed 7 digits spaced correctly, centered, and upside down onto an LCD. Thanks, Gaben. After I had the LCD working correctly, the rest of the work was making the microcontroller pull the keypad for inputs, writing some functions to drive the RGB LED, implementing the logic state machine that the in-game C4 has, and driving the piezo buzzer to generate the beeps. Driving the piezo buzzer was actually a surprisingly interesting aspect of the code. A very obscure and useless piece of information is that the frequency of the C4 beep in-game depends on which bomb site it's planted at. Luckily, others on Reddit have already done the hard work needed to make the C4 beep at the same increasing cadence as it does in-game. I implemented the equation they figured out, and bam, it matches the in-game beeping. With the software done, it came time to try powering the circuit board by battery instead of USB. When I wired up the switch assembly to a 9-volt battery, I found that it couldn't provide enough current to the circuit and the voltage would rapidly drop off. I needed more power. Now we're talking. I bought a completely overkill battery designed to power hobbyist RC cars and rewired the switch assembly to hook it up. Much better. With the electronics done, it was time to work on the rest of the replica. I haven't really done any prop making before, but I channeled my inner Adam Savage and got to work.
body, feel my body on you. If you leave out with somebody, let it be my body, feel my body on you.
Activating the bomb. It is going to explode. Terrorists win. Bomb has been defused. Counter-terrorists win. We're in the clear, lads.
This is a brand new YouTube channel, and I hope to make more videos soon doing cool builds just like this one. If you like the video, please subscribe. Thanks for watching.